I think the biggest thing that makes it unique is this sort of blend of guided inquiry activities where students are working sort of hands-on, doing little experiments every day. And then at the end of the course, they do student-directed projects. So they actually become the scientific investigator, and they work on a project of their own design. And I don't know any other curriculum that mixes those two things the way EIP does. You literally have to be a scientist. You have to help them ask the right questions and lead them to experiments that will answer these questions. But you don't necessarily know the answers up front. And that's a little bit frustrating for the students at first because they think that you should just answer this. But once they realize that you don't really know and they might figure it out first, they get really empowered by that. So that's an exciting aspect of the course. There's nothing quite like that aha moment when you figure something out by looking at a graph or something and say, ah, that's how it works. And to think that the instructor doesn't even know, that's pretty exciting. I think the biggest thing that was missing in traditional courses is a real understanding of the process of science. So there's this scientific method, as it's called, that's taught in schools. And there's these step-by-step things that you do when you do science. But if you ask any scientist, no one follows the scientific method like that. It just doesn't work that way. It's a much more creative endeavor. And while some of those points in the scientific method are things that we always keep in mind, it's just not so clear. You don't go step by step by step by step like that. So, and the only way to really understand the process of science, I think, is to do it, to actually do science the way that a scientist does it. And by having our students work on these projects, they really come to grips with what it means to do science and to understand some of the subtle errors and inconsistencies that they have to learn to sort of tolerate in some sense to come up with an answer. A typical lab instruction is much more, we call it cookbookish. There's an apparatus that's sort of already set up, and there's an instruction sheet, and the students come in, and they sort of, oh, I'm supposed to turn the dial to 9, and I push this button, and I see what the number says, and I write it down. And they're not really called to do any sort of higher order thinking. And in EIP, the whole course is based on higher order thinking. So there still might be equipment and there might be some general instructions for an experiment to do. But the students have to grapple with what does this graph mean? What is it actually telling us? And what kind of inferences can we draw from that? When I first started working on EIP, I thought of it as a revolution. I was just very excited because there was nothing like this. And it was a lot of fun to teach. I could see the students were having a lot of fun. And I think my hopes is that this kind of a course can act as a model, not just for other kinds of courses in physics, but for any of the sciences. I can imagine courses like this being taught in biology and chemistry, astronomy, earth science, anything really. When we developed this course, it was developed as an introductory college-level lab science course. But we've had a lot of people contact us over the years in high schools mainly saying, gosh, could we use this with high school students? And our response is always, well, certainly, but you might have to modify some of the activities. You might not be able to depend on, quite the capabilities that we would depend on in college-level students. So I think they could be used at almost any level. But you'd have to modify things slightly.